The story we have been told about the universe's genesis might be a cosmic fabrication. A new theory dares to question the ultimate origin, suggesting that the Big Bang wasn't the starting gun.
When the James Webb Space Telescope, JWST, sent back its first round of deep space data, it didn't just give us jaw-dropping images, it flipped the entire science world on its head. One of the most shocking bombshells. Scientists found what looks like over 750 ancient galaxies sitting way beyond where the known edge of the universe is supposed to be. That discovery hit cosmology like a freight train, and no one stirred the pot harder than wildcard physicist Michio Kaku, who hinted this could completely shake, or even destroy, the Big Bang theory as we know it. Smash that like button and subscribe before we go deeper into this cosmic chaos. Let's break this down. The Big Bang theory says everything started from one tiny, super-dense point about 13.8 billion years ago. Space, time, matter, all of it. And it's been expanding ever since. Scientists back it up using things like cosmic microwave background radiation, redshift data, and how light elements are spread out. But then JWST rolled in with its insane sensitivity and clarity. And now the old story ain't adding up. What stunned scientists wasn't just the number of galaxies, it was how grown-up they looked. These galaxies seem mature, massive, and seriously well-structured. We're talking spiral arms, galactic bulges, the whole package. And that's a huge problem, because galaxies are supposed to take billions of years to reach that level. These babies look like they've been around forever. But they were found in a time period when the universe was just a toddler. That's like finding a fully built skyscraper in the middle of a town that was just founded yesterday. Something's off, way off. But things got even crazier when JWST picked up hundreds of galaxies that, based on redshift analysis, existed only 300 million years after the universe supposedly began. That alone would have been a wild headline. But what came next? Straight up mind-blowing. The real twist came from how these galaxies were arranged in space and how their light spread out. The data showed they were sitting past the edge of the known observable universe. Yeah, you heard that right. They're chilling outside the zone where light should even be able to reach us. So what does that even mean? Well, the observable universe isn't a wall or barrier. It's just the farthest distance light has had time to travel since the Big Bang. Since light moves at a set speed and the universe is about 13.8 billion years old, we shouldn't be able to see anything past a 93 billion light-year wide bubble. But here's the problem. If we're spotting galaxies outside that bubble, then something's seriously messed up. Either the way we understand space-time is broken, or the way the universe is expanding is way off. Enter Michio Kaku, the physics rock star and string theory expert. He didn't waste a second before jumping on this cosmic drama. Kaku pointed out that if this discovery holds up, it could completely shatter the base assumptions behind the Big Bang theory. In his breakdown, Kaku laid out several heavy-hitting possibilities, and every single one could rewrite what we thought we knew about the origin of everything. First up, the whole idea that time and space started from a single point. That might be totally wrong. Second, the universe may not be expanding from just one origin like we thought. It could be part of some giant, tangled, maybe even infinite structure. And third, if galaxies really do exist beyond the limits of what we can observe, then either our tools are straight up broken, or this universe is way older and bigger than we ever imagined. This ain't just a tiny theory tweak. This is a full-blown scientific earthquake. The Big Bang theory has been the main storyline in cosmology for decades. It's been taught in classrooms, printed in textbooks, and repeated like gospel. But let's be real, it's never been perfect. Even scientists admit it's had holes. For starters, it struggles to explain why the universe is so even in temperature, even across billions of light years. It also stumbles when trying to explain how inflation exploded so fast, or what the heck happened before the supposed bang. These questions were always tossed to the side like, we'll figure that out later. But JWST's discoveries just slammed those questions back on the table, louder and messier than ever. Now, some experts are saying maybe the Big Bang wasn't even a one-time deal. Those old-looking galaxies showing up way too early. They could be proof that the universe existed long before what we thought was the beginning. That fits right in with ideas like the cyclic or bouncing universe models, where the cosmos keeps going through never-ending loops of expansion and collapse. In that theory, what we call the Big Bang might just be one boom in a long chain of cosmic resets. And if that's the case, then time itself didn't begin with the Big Bang. It just kept on ticking. What if our universe didn't start fresh, but actually inherited structure and even leftover matter from a previous cosmic cycle? That would totally explain why some of those early galaxies look way too mature for their age. Some of them might not be early at all. They could be recycled galaxies, survivors from a past universe that got rebooted. In that light, the discovery of those 750 ancient galaxies at impossible distances stops looking like a glitch and starts looking like a peek into an older, maybe even eternal universe. That's not just a data point. That's a whole new doorway into cosmic history. Michio Kaku didn't stop there. He dropped even more heat by linking this to our understanding of dark matter and dark energy. If galaxies exist outside what we can observe, then dark matter might not just be some invisible cloak around galaxies. It could be part of a massive cosmic network we can't fully see. And what about dark energy? The mysterious force speeding up the universe's expansion. Kaku suggested it might not be a force at all, but a side effect of a huge multi-dimensional structure. Everything we think we know could just be the shadows of a deeper reality playing out way beyond our field of view. But wait, it gets even more twisted. The shape of the universe itself might be nothing like we thought. If those galaxies really are where they seem to be, then space may not be flat, or even gently curved. We could be staring into massive warped zones of space-time, bending and looping in ways we can't yet imagine. We might be living in a universe that folds, twists, and stretches through dimensions we haven't even discovered yet. This whole wild idea isn't just sci-fi talk. It's actually backed by string theory and brain cosmology, fields where Michio Kaku has been grinding for decades. These theories say our universe might just be a 3D membrane, or brain, floating inside a much bigger, higher dimensional space. So when we see the universe expanding, we might actually be watching it move through hidden dimensions we can't even detect. Now here's where it gets crazier. Finding galaxies outside the observable edge has forced scientists to rethink cosmic inflation. According to that theory, the universe exploded faster than light right after the Big Bang, in just a blink, smoothing out all the weird bumps and wrinkles to create the uniform universe we see today. But guess what? These old, mature galaxies don't fit that story at all. If inflation really happened the way we thought, we shouldn't be seeing fully formed galaxies that early. So now there's a new theory on the block. Maybe inflation didn't wipe out everything before it. Maybe some ancient cosmic leftovers survived. That would mean we're seeing relics from before inflation even started, pieces of a universe that existed before ours officially began. And some scientists are pushing it even further. They think we might be staring at the edge of another universe entirely. Yep, you heard that right. A whole other bubble universe. Different laws, different rules, and a completely different reality. That would mean our Big Bang, not so special, just one boom in an endless multiverse where every explosion creates a whole new universe. If that's true, then those 750 galaxies JWST spotted, they're not just old. They might be the first real proof that we're living in a multiverse. One universe in a cosmic jungle full of others. We're talking about something way beyond anything humans have ever wrapped their heads around. And it's not just the world of theoretical physics that's getting shaken up. Observational astronomy is facing a serious reality check too. If the James Webb Telescope is out here catching light from beyond the known edge of the universe, then one of two things has to be true. Either our models of the universe are totally incomplete, or space and time are playing by rules we haven't even discovered yet. And let's not forget the tools we use to measure all this. Those distance estimates based on redshift. They might need a full reboot. We're talking about reworking the algorithms, maybe even inventing entirely new models just to figure out what JWST is actually showing us. This isn't just about solving one mystery. These discoveries blow the doors wide open on the origin and fate of the universe itself. If the Big Bang wasn't the real beginning, then the question of where we came from becomes not just deep, but urgent. What came before? What started the cycle? If we're even in a cycle? And maybe the wildest question of all, what's coming next? If we're living in a cyclic universe, then one day everything could collapse, only to bounce back in another Big Bang. If it's a multiverse, then maybe there's no end at all. just an infinite creation loop with new universes constantly being born. Michio Kaku isn't out here claiming he's got all the answers, but he's cracking the door wide open and flooding the room with questions. He's calling on scientists, thinkers, and cosmic dreamers to challenge the sacred beliefs we've held on to for generations. If we let go of the Big Bang as the one and only starting point, we're finally free to explore wild ideas, where time loops, space breathes, and universes grow like branches on a living tree. This isn't the end of cosmology. This might be its true rebirth. Every time new data drops from the James Webb Space Telescope, it hits like a cosmic thunderbolt. This telescope wasn't built just to see farther. It was built to rip through time itself and expose the deepest secrets of the universe. And what it's found so far, it's not just strange. It's stranger than we ever thought possible, maybe even stranger than we're capable of imagining. Under the old rules, these galaxies were just distant lights in the sky, but now they're looking more like cosmic messages, signals from a universe that could be older, bigger, and way more complex than anything the Big Bang ever explained. Right now, the detection of 750 galaxies sitting outside our supposed cosmic boundary is both a scientific miracle and a serious wake-up call. This isn't just about seeing more, it's about thinking differently. It's a direct challenge to the scientific world, a loud demand to revisit the core questions about where we came from, how everything started, and what the universe even is. And you better believe physicists, cosmologists, and space experts will be arguing, testing, and flipping theories inside out for years, maybe decades, to come. But one thing's crystal clear. This story, it's nowhere near over. In fact, JWST didn't just add a new chapter. It ripped the old book in half and started writing a whole new one. This discovery, over 750 galaxies where we never expected to see anything, doesn't just stretch what we already knew, it pushes us to the very edge of human understanding. As more data rolls in, things are starting to click, and a brand new picture is forming. One that could completely rewrite not just how the universe began, but what it's made of, how it moves, and where it's going next. The real shockwave from JWST's discovery isn't just about seeing galaxies we didn't expect. It's about what those galaxies mean on a deeper, mind-bending level. This goes way past science and crashes straight into the world of philosophy and theoretical physics, the stuff we used to think was out of reach. One of the biggest plot twists, it hits time itself. In the Big Bang model, time has a clear beginning. Boom, the universe starts, and the cosmic clock begins to tick. But now, that whole idea might be falling apart. If these galaxies were already evolved and structured way earlier than we thought possible, and they came from beyond our cosmic limits, then we might have to completely rethink the arrow of time. How could galaxies be that complex so soon after the beginning? Either things formed at a freakishly fast pace, or time didn't move the way we thought it did back then. Or, get this, maybe what we're calling early wasn't early at all. This opens the door to a wild idea most people only heard about in deep theory circles: time asymmetry. We always assume time flows the same everywhere, nice and smooth. But what if it doesn't? What if time moves at different speeds in different zones of the universe? Or even crazier, what if our version of the beginning was just a local glitch, while other regions in the universe or even the multiverse run on totally different time rules? Those galaxies JWST found, they might be in places where time has been moving faster, letting them grow up while our part of the universe was still learning to crawl. That means we're not just looking out into space, we're peeking into zones where time itself plays by different rules. That little phrase scientists love to throw around, cosmic variance, just took on a whole new meaning. It used to describe tiny differences in the cosmic microwave background, like small ripples in temperature and density. But now, we might be talking about entire cosmic zones where gravity, time, and even dimensions work completely differently. That means our observable universe could be just one patch in a way bigger cosmic quilt. And each patch might follow its own set of rules. Different physics, different time flow, different everything. And here's the kicker. If that's true, then the idea of a theory of everything, the one holy grail that unites gravity, quantum mechanics, and all the forces of nature, might be a fantasy. Think about it. If other parts of the universe run on completely different laws, then maybe there isn't one neat equation to tie it all together. That dream of a single unifying code might be less about the universe and more about how humans want it to work. This throws the whole job of physicists into chaos. Now they're not just trying to find math that makes sense. They've got to build models that can handle contradictions, change, and maybe even cosmic rule breaking. That's a huge shift in how we think about science. It's not just about neat answers anymore. It's about embracing the wild, unpredictable diversity of the cosmos itself. And here's the twist. All this madness lines up with what string theory and M theory have been hinting at for years. Multiple dimensions, parallel worlds, and brane universes all crashing and colliding, with each one playing by its own physics. So yeah, the universe might not be playing fair, but it's definitely playing big. Michio Kaku's been riding for string theory and higher dimensions for years, and now JWST might have just handed him the receipts. The galaxies found beyond what we thought was the edge of space could be leaking in from other dimensions. Yeah, you heard that right. We're talking parallel universes where light slips into our realm through invisible gravitational tunnels or even quantum bridges between different branes. These aren't just theories anymore. Now there's real data that might be pointing straight at them. And this discovery doesn't stop there. It's shaking up how we picture the shape of the universe, the entire topology of everything. We used to think the universe was flat, or close to it, like a giant, ever-expanding sheet. But what if it's not flat at all? What if it's twisted, warped, and looping around itself in weird, mind-bending ways we never expected? If that's the case, then light might travel through multiple paths, bending around curves in space and showing up in places it's not supposed to. That could explain why some galaxies look like they're repeating, popping up in different locations like cosmic déjà vu. This has already been hinted at with gravitational lensing, where massive objects bend light and give us double images of the same thing. But what JWST found suggests we're dealing with this on a way bigger, scarier scale, and that brings us to something even deeper: the true nature of light itself. Light is our main tool for peeking into the universe. We track its redshift to figure out how far stuff is and how fast it's flying away as space expands. But now, even light's journey might not be what we thought. But here's the real brain buster. If these 750 galaxies are sitting beyond the point where light should have had time to reach us in 13.8 billion years, then we've got a serious problem. Either our redshift calculations are flawed, or something we've always believed about light itself might be totally wrong. This throws open the door to a dangerous question. What if the speed of light isn't constant? We treat it like one of the universe's unbreakable rules. But what if that speed has actually changed over time, or shifts under different conditions like gravity or quantum forces? That idea has been considered heresy in standard physics circles, but now JWST might have just handed us the first real evidence to test it. If the speed of light isn't fixed, everything we've built, from measuring how far galaxies are, to calculating how old they are, to how fast the universe is stretching, might have to be rewritten from scratch. And that's not even the end of it. Some researchers are now digging into the wild world of quantum entanglement, where two particles can be separated by light years and still influence each other instantly. It sounds like sci-fi, but it's been proven in labs. And now they're asking, could this be happening across the entire cosmos? Imagine parts of the universe being entangled, connected in hidden ways we can't see, like invisible wires running through space, syncing up galaxies light years apart. That would mean the structure we see out there, those patterns and clusters, might actually be the surface level effect of deeper cosmic level connections that defy distance, time, and even the speed of light. For years, astrophysics played by the rules. The universe had a beginning, a structure, and an ending. It was massive, yes, but self-contained. Now, that entire framework just got ripped wide open. Suddenly, the questions that once sounded like sci-fi nonsense are now serious science. Are we living in a simulation? Is our universe just one bubble in a massive cosmic foam? And are we sitting in a central spot? Or are we just a tiny speck on the edge of something way bigger? These ideas aren't just late-night debate topics anymore. They're about to shape real-world science. Space agencies, funding committees, and next-gen telescope missions will start chasing clues that go beyond what we used to think were the limits. We're talking telescopes built to search outside the box, maybe even tracking gravitational waves or distortions that could point to other universes lurking just out of sight. Future missions could aim to map invisible forces pulling at our galaxy, not from inside, but from somewhere beyond the observable cosmos. Whole new branches of science could emerge, like cosmic archaeology, digging not just into the history of our universe, but into its possible links to others. And here's where things get wild. AI is already in the game. With JWST pumping out mountains of galactic data, machine learning is helping scientists spot patterns no human could catch. It's already scanning light curves, galactic shapes, and strange formations, and picking out things that look off. Thousands of potential anomalies, and it's just getting started. AI might be the key to seeing the parts of the universe our eyes were never built to find. Studying AI isn't just helpful anymore. It's about to become absolutely essential. As the universe keeps throwing curveballs, AI will be our best shot at spotting the faint signals of other universes, exotic forms of matter, or even hidden dimensions that no human eye could ever detect. But let's go deeper. This discovery isn't just shaking up science, it's shaking up the human soul. Once again, we're staring into the night sky, asking those ancient questions. What's our place in all this? Are we really alone? And this time, it's not just about life out there. It's about the architecture of reality itself. Religious and spiritual ideas that once fit neatly next to the Big Bang story are now facing something way bigger. What if there was no single beginning? No clean, straight timeline, no final cosmic edge, just limitless expansion in every direction, physical, dimensional, informational. If the very rules of space, time, and matter are incomplete, then maybe we don't even fully understand what it means for something to exist. Those galaxies JWST uncovered, they might belong to a whole deeper layer of reality, what some theorists are now calling the metaverse. And no, we're not talking about some digital playground. This is the real deal, a level of existence that holds not just our universe, but all possible worlds built from physics, math, and code we haven't even touched yet. Think of it like this: our universe could be one page in an infinite cosmic book, and JWST, it may have just turned the page, and now space exploration will never be the same. If certain regions of the universe run on different physics, then travel, communication, even survival in those areas could work in ways we've never imagined. Wormholes, time warps, and quantum jumps, once dismissed as sci-fi buzzwords, might be the actual tools we need to navigate this insane new map of reality. The future of humanity in space, from building colonies to crossing into other dimensions, could all depend on understanding these wild galaxies JWST just revealed. Now the ethical questions are creeping in, and they're heavier than ever. If we're not just unlocking more of our own universe, but also brushing up against other universes, what kind of responsibility comes with that? Could there be life, intelligence, or even full-blown civilizations out there in those hidden realms? And if so, what's our role? Are we explorers, observers, or intruders in something way bigger than us? We've known for centuries that Earth isn't the center of the universe, but this takes it even further. We might not even be in the main storyline of the cosmic book. We could be a side note, a forgotten paragraph in a massive multiverse epic we barely understand. This changes the whole picture. The universe, or universes, aren't just empty space or distant stars. They're alive, shifting, folding, and growing in complexity. We're not looking at a static painting anymore. We're inside a living, breathing system that's been evolving since before time as we know it. And those 750 galaxies JWST uncovered, they're not just far away, they're cosmic invitations. Invitations to think harder, dig deeper, and face the truth. We barely know anything about the full scope of reality. As more data rolls in, the universe is whispering something it's held from us for a long time. The story of existence is older, bigger, and weirder than we ever dared imagine. The implications of JWST's discovery are still unfolding, and it's not just about charting stars or ticking boxes in a database. This is about redefining our place in everything. These galaxies are shaking the very core of how science sees reality, and we're only just getting started. These discoveries are shaking the very foundation of everything we thought we knew. Causality, scale, and even the nature of existence itself are now up for debate. At the core of this cosmic chaos sits a question we used to think was answered: how did everything begin? But now, that question might have been wrong from the start. To even begin solving this mystery, we've got to take a hard look at the assumptions scientists have used for decades to make sense of the universe. One of the biggest, that the universe is homogeneous and isotropic, meaning it looks the same in every direction and from every spot. That idea worked under the Big Bang model. It gave us a framework to measure redshift, track cosmic microwave background radiation, and study the way galaxies are spread out. But if galaxies are popping up beyond the edge of where they should exist, in regions outside the causal limits of our universe, then all those assumptions just got torched. If the universe isn't isotropic, if it actually changes depending on where you look or where you are, then we're not living in one smooth cosmic soup. We're in a universe that might be patchy, layered, or even compartmentalized in ways nobody ever imagined. One wild but possible explanation: we're seeing an observable intrusion from some hidden, folded-up structure that exists inside our own universe, not outside it. It's just so complex, it looks like something foreign. Think of it like this. Our universe could have extra spatial dimensions curled up and looped in strange ways, bending light in directions that totally fool our eyes and tools. So what we're seeing might not be another universe after all. It might be a twisted, folded part of our own, hiding right in plain sight. Now here's where things get seriously twisted. What if those galaxies we think are way out past the edge of the universe are actually much closer than we think? What if they only look far because they're caught in some kind of spatial illusion? That's exactly what some scientists are now saying. Thanks to gravitational lensing, massive structures we can't even see might be bending space so hard that it's distorting the light, making nearby galaxies appear like they're sitting billions of light years away. This drops us straight into the world of higher dimensional physics, where the rules are weirder than anything we deal with on Earth. Here, you've got string theory, quantum loop gravity, and emergent space-time theories all coming into play. Forget the idea of space as a big empty box. In these models, space isn't a container. It's a product of quantum relationships. A galaxy's location isn't fixed. It's just the outcome of interactions between vibrating strings, energy fields, or even raw information networks. So in this new framework, galaxies might not be traveling across insane distances at all. They could be emerging, appearing in different places based on fluctuations in some deep, invisible layer of reality. Think of the universe not as a balloon inflating from a central point, but more like a shifting spider web where things pop up not because of location, but because of pattern and connection. And it doesn't stop there. This throws major shade on redshift, the tool we've used for decades to measure distance and speed in the universe. We always assumed redshift happened because space was expanding, stretching light as it moved through the cosmos. But what if that's not the full story? What if redshift can also be altered by interactions with exotic particles, by slipping through extra dimensions, or even by temporal distortions we don't understand yet? That would mean our measurements of distance, age, and expansion could be dead wrong. What if those galaxies aren't as old or as far as the redshift data claims? What if they're just getting scrambled by strange, unknown forces in the space between us and them, throwing off our whole sense of distance and time? That would mean our entire cosmic timeline is up for grabs. Maybe galaxies don't take billions of years to evolve into complex structures after all. Maybe, under the right conditions we haven't even discovered yet, maturity comes fast, like unbelievably fast. Or maybe our models are just plain biased, warped by the limitations of how we've been observing the universe all along. And now, the James Webb Space Telescope is starting to peel back those blind spots, revealing flaws we didn't even know we had. If that's true, then we're not just tweaking a few theories, we're staring down a full-on cosmic reformation. A revolution where it's not just the data that gets questioned, but the entire method of how we observe and interpret the universe. But here comes the next curveball, and it's a big one. What if our own consciousness plays a role in this? Quantum physics has long hinted that the very act of observing can affect the outcome of what we see, collapsing wave functions, shifting probabilities, changing the state of things on a subatomic level. Now imagine that same effect, scaled up. What if our observation of galaxies isn't just about recording light, but actually influencing the way the universe responds? What if, just by looking deeper, we're causing new structures to appear, shaping reality with our curiosity? This isn't just science anymore. It's bordering on participatory cosmology, a wild idea that says the universe isn't just sitting there waiting to be discovered. It's responding, interacting, maybe even evolving with us in real time. In that view, humanity isn't some small bystander in a massive universe. We're co-creators, helping write the story as we try to read it. This new way of thinking flips the entire universe on its head. What if reality itself is a kind of cosmic dance between observation, interaction, and self-organizing energy? In this model, the galaxies seen beyond the observable edge might not have always been there. They could be emergent structures, popping into clarity only now because our technology has finally become precise enough to tune into them. It's not just about what's out there, it's about how we're looking and how the universe responds to being seen. Some scientists are also coming at the mystery from a whole different angle, by looking at it through the lens of thermodynamics and entropy. If those galaxies really do exist way beyond what we thought possible, then the entropy, or cosmic disorder, of the universe might be way higher than we ever expected. And that changes everything. A higher entropy universe means more chaos, more energy, and possibly a universe that's not dying off quietly like the Big Freeze or tearing itself apart in the Big Rip. It might be richer, louder, and more alive than any of those old predictions could ever explain. In this wild, high-entropy model, the Big Bang might not have been the start of it all, just a temporary dip in a sea of universal chaos. A rare pocket of low entropy where things suddenly got calm enough to form matter, stars, galaxies, and us. Basically, our whole universe could be a statistical blip, a tiny calm bubble floating in a roaring cosmic storm. And that could explain something else that's puzzled scientists for years. Why time only moves forward in our universe. If the Big Bang was just an entropy reversal, time here flows from order to chaos. But in other parts of the multiverse, time might move differently, or not at all. This wild theory also cracks open another mind-blowing idea. What if there wasn't just one Big Bang, but countless Big Bang-style events happening all across the broader cosmos, each one launching its own version of time, its own physics, and its own unique entropy flow? That leads to something even more disruptive, the possibility of a fractal universe. Yeah, a reality built like a never-ending cosmic pattern, repeating at every level, echoing across time and scale like a loop design that never stops. In a fractal cosmology, the universe is made up of recursive structures, one layer folding into the next, just like nature already shows us. Think about it. We already see this in coastlines, clouds, river networks, even in the firing patterns of our brains. Fractals are everywhere, and the universe itself might be the biggest fractal of them all. That means galaxies, star clusters, and even entire superstructures are just one layer in a deeper, infinite cosmic nesting doll. And those 750 galaxies that JWST just uncovered, they might be the first signs of an undiscovered tier in this massive repeating system. This even revives the idea of infinite universes, not just infinite in number, but in size, depth, and complexity. Universes inside universes, each one built like a cosmic matryoshka doll, going deeper forever. In this kind of universe, we may never find a real edge, no final beginning, no ultimate starting point. Every limit we cross just reveals a new layer, another hidden structure, another piece of the cosmic onion peeled back. And behind it, even more. Those 750 galaxies aren't mistakes or intrusions. They're inevitable, a natural consequence of how deep and recursive this reality might be. And if that's true, then the whole idea of the beginning, that human craving to trace everything back to one single origin, might be the biggest illusion of all. Even the idea of time might be just a local effect, a rule that only applies in our small pocket of the universe. In a twisted, multi-layered, non-linear cosmos, the belief in a single starting point, that's yesterday's news. It may have always been just a side effect of limited perspective, not some universal truth. Existence, then, isn't a trip from point A to point B. It's a wild, never-ending unfolding, A cosmic buildup of layers, structures, and mysteries stacked one on top of another with no final stop in sight, but it doesn't stop there. The discovery of these far-out galaxies also forces us to rethink cosmic communication. If light from beyond the old horizon is reaching us now, maybe the universe isn't as sealed off as we thought. Maybe it's way more porous, way more connected than anyone imagined. That means we might someday be able to send or receive signals through things like neutrinos, gravitational waves, or even quantum entanglement, all across distances that used to sound totally impossible. And here's the next big step. Building the right tools. The next-gen telescopes won't just look farther. They'll reach sideways into dimensions, scanning for data not just from across space, but from entirely different layers of existence. We're talking quantum sensors, gravitational detectors, and tech that picks up on the echoes and tremors of hidden realities. Not just light and sound, but the raw signals of other worlds colliding with our own. So, if you were blown away by this journey through space, time, and everything beyond, go ahead and like this video, subscribe to the channel, and don't forget to share it with someone who needs their mind blown too.
Drop your thoughts in the comments. Do you think the Big Bang has been debunked after JWST's Galaxy bombshell? We're reading everything you post.
Thanks for watching, and we'll catch you in the next one, where the universe might be even stranger than we just saw.